Alright, so example 1. When 80 grams of copper and 25 grams of sulfur react, which reactant is in limiting and what is the maximum amount of copper 1 sulfide that can be produced? Well, copper reacting with sulfur gives me copper 1 sulfide, okay? And this is in a 16 to 1 to 8, okay? I want the amount of copper 1 sulfide, the mass specifically of it that can be produced, and I can figure out the molar mass quite simply. I'm told that I've been given 80 grams of copper at a molar mass of 63.55 grams per mole, and I'm given 25 grams of sulfur at 256.56 grams per mole. Figure out the number of moles. For copper, I take 80 grams and divide it by the molar mass, okay, and that gives me 1.25 moles. I do the same for sulfur, okay, and that is going to give me 0.0974 moles. But that is not the end of the story. I then have to take these numbers and divide them by the coefficients that go along with those. So I'm going to take 1.25 moles and divide it by 16, and that'll give me 0.0786 moles of copper, okay? And I compare that, obviously I'm only dividing by 1 for sulfur, and that still leaves me with 0.0974 moles, which means, therefore, that copper metal is the limiting reagent, even though it was in a much higher mass, okay? And the sulfur is actually the excess. So then I'm going to take the number of moles that I have for my limiting reagent, and I'm going to use that in determining the amount of copper 1 sulfide that can be produced. So I take that value, and I'm going to multiply that by wanted over given, which in this case is 8 by 16, okay, and I get 0.629 moles. I'm going to then take that amount, and I'm going to figure out my mass by taking that amount and multiplying it by the molar mass of copper 1 sulfide. And that gives me 100.17 grams, okay, or 100 grams. Now for my second example, here you are supplied with 9 grams of potassium chloride and 6.5 grams of AgNO3. So what is the mass of precipitate formed when these two chemicals react? So the first thing that I have to do is I have to write out the equation. I have to balance it. In this case it's pretty simple because it's a 1 to 1 to 1 to 1 ratio. Now I have my mass and molar mass of both of the reactants, and I'm trying to figure out the amount of precipitate, which in this case is AgCl. Molar mass there is 143.32 grams per mole. So I need to figure out the number of moles of both of my reactants, and I use that by taking the mass and dividing it by the molar mass in both cases. Okay? Now I then take those amounts and I have to divide them by the coefficients for each, but in this case it's 1. So really, I should have just used those original numbers. Anyways, my potassium chloride is what is in excess. Okay, so I then take this limiting amount of moles and I multiply it by the mole ratio of wanted over given, okay, which in this case is 1 to 1. And I then multiply that by my molar mass, which gives me then finally 5.48 grams. A third example here is 200 milliliters of a 0.221 mole per liter mercury 2 chloride solution reacts with 100 milliliters of a 0.500 mole per liter solution of sodium sulfide. What is the mass of the precipitate formed? Well, in this case I'm using solution stoichiometry, okay, and to figure out the number of moles, okay, and it's asking me finally what the mass of precipitate is formed. So I figure out the number of moles of both my reactants, which is pretty simple, okay. I then divide by their coefficients, which happens to be 1, so I'm okay there, and I figure out that my mercury 2 chloride solution is the limiting. I'm then going to use that number of moles, the one of my limiting reactant, to figure out the mass of precipitate, which is 10.3 grams. We're going to talk about predicted and experimental yield in the next video.